All right. I actually already recorded this one too, but this is actually supposed to be an intro to the Solow growth model that we're going to talk about next class. I want to give you an introduction actually with a different model, one that's not in the textbook. So let me just make sure that I'm recording the right screen here. If you watch my other video where I talk over my slides, you're actually looking at me the entire time because I didn't have the slides up when I was marking them up. But in any case, let's think about a very simple economy. Suppose we've got a certain amount of land, let's call it fields. So X is the number of fields, let's call it 1 for now. And suppose we've got 2 workers for that one field. All right. And let's just draw our little field here. This way. Okay, here's a nice field. We got a couple of workers. One guy's kind of far away. Here he is over there. One guy's a lot closer. He's like up here. All right, so suppose that if we have 2 workers on one field, then we can get 1 box of wheat. All right, now suppose that we have, rather than 1 field and 2 workers, suppose we instead have 2 fields and 4 workers. Draw another field over here. Get a couple of workers. These guys are both up here. They're just hanging out at the front of the field. Well, these guys are also going to be able to create 1 box of wheat. If we double the amount of inputs, it's very reasonable to think that we will double the amount of outputs. Okay? But now suppose we're in a different situation. Suppose that we have only 1 field, but we have 4 workers. Okay? So it's the same 1 field. The same 1 field, but now we've got 2 guys in the back. We got 2 guys up front. Getting a little crowded on that field. So as we increase the number of workers, we're probably going to increase the amount of wheat we can get. So maybe we can get, rather than just 1 box of wheat, we can get more than 1 box, but we're not going to get 2 boxes. You know, you can't double the amount of wheat you get from some land just by doubling the amount of workers. Maybe instead we get 1 big box and 1 little box of wheat. This one just has a W on it. So the idea here is that the output of 1 additional worker fixing the amount of land is going to be decreasing as we increase the number of workers. You know, this is a very reasonable idea to me. So if you think about, say, my favorite analogy, if we think about cake, you know, if we double the amount of inputs, double the eggs, double the flour, double the time, we can get twice as much cake. But if we only double some of the inputs, we're not going to get twice as much cake. Okay, so that idea actually is sort of an old idea. It comes from an economist. I don't know if he would have thought of himself as an economist, but a thinker at least, named Thomas Malthus. And this idea is called the Malthusian trap. That population growth makes everyone poorer. Okay, and you know, it's an idea that came out of, I think, agricultural economies. Malthus was writing, I believe, in the early 19th century, when agriculture was the primary industry where most labor was employed. But it's also quite prominent today. So people think about, say, in a slightly different context, they think about guess what I'm drawing before I draw it. Think about the Earth. Here's the Earth, which is blue with a little bit of continents on it, you can see. This is the way that somebody would draw the Earth if they had never been to the Earth. But that's my rendering of the Earth, and here's the moon. All right. So, you know, the Earth is this bundle of materials, resources, that's orbiting around the sun. Okay, so in some very real sense, there's a finite amount of resources, right? So it's natural to think that as we increase the number of people, there's no way that we can keep increasing production forever. Eventually we run into some limit. Okay, that's this very prominent Malthusian idea that again, kind of grew out of agricultural economies because land was such an important input that was hard to increase, kind of have the amount of land you have, but also is a modern environmental idea as well. Okay, we can formalize that by writing down a couple of equations. So let's think about production as being something that combines resources and labor. Okay, so the amount of output we have is in an economy might be some function of resources and labor. And just to be specific, let's say that it looks like this. It's the amount of land you have times the amount of laborers to the power alpha, where alpha is some number in between 0 and 1. Okay, so what this says is we're going to graph this thing out, graph the production function. If we fix the amount of land and then graph how production is going to change as we increase the amount of labor, as population grows if you like, then this is going to look something like this. It's going to be a concave function. Right? Now let's ask ourselves, well, first of all, let's actually write that out. So what is the dF dL? How does production change as we increase the number of workers? Well, it's going to be x times alpha times L to the power alpha minus 1. And since we've assumed that alpha is between 0 and 1, this is negative, so it says that this is always positive, but the rate is decreasing, right? So the slope of this function is getting lower as L gets bigger. All right. So let's actually think about the amount of production we have. This is what I should have done first, actually. How much output do we have per worker in this economy? Okay, well, that's just x L alpha divided by L, which is equal to x times L to the power alpha minus 1. And again, as I just set up here, this is what I probably should have done first. This is negative, so it means that L here is in the denominator. So it means that if we think about y divided by L, that's actually a function that looks like that. So as we get more and more labor, there's less and less output per capita. Okay, so the final kind of step in the Malthusian economy is that there's some minimum amount of output that you need to survive, some amount of food, say, you need to survive. And once the population grows beyond that point, there's famine, and then the population drops down again. That's known as the Malthusian trap. All right. So that's really all I have to say about Malthus, but you know, what we're going to talk about today is actually the Solow growth model. Okay, so what is it that makes the Solow growth model different from the Malthusian model? Well, it's mostly kind of an assumption about the nature of resources. Okay, so in the Malthusian model, we said that there's land and there's very little you can do about the amount of land you have. Okay, in the Solow growth model, we're going to be focusing on a different name for resources. We're going to be focusing on capital. Okay, you know, this is a model of capitalism. So, so capital is going to be resources that can be built up. Okay, so it's something that you can actually add to over time. And you know, there's something to this, of course. I mean, if you think about the real world and you think about, you know, you can build buildings, you can use those buildings over time, or machinery can make us more productive over time, or just you going to Copenhagen Business School to get an education, that's making you more productive, right? So, you know, there really is to this idea, there's something to this idea of being able to build productive resources that are going to increase over time. But you know, there's also something to the idea that there's limits to that process, right? So, so anyway, this Solow growth model, you can think about it as a way that we can model the escape from the Malthusian trap. We can actually model the way that resources increase as we invest in them. Right. So I'm going to stop there, and now you can go back and watch my, if you want to see more, you can watch my video on the slides for the Solow model.